All right, so the definition of a geometric sequence just says here, basically, guys, to find that common ratio, you're going to take your second term divided by your first term, or you could take your third term divided by your second, or your fourth term divided by your third term. You take your 10th term divided by your 9th term. Just like before, you can take a term, but this time you divide it by the term in front of it. That's how you find that common ratio. So let's do this in example 1. So for each of the geometric sequences, find the common ratio. So for the first one here, what can I use to find my common ratio?
9 divided by 3.
Okay, what if I don't want to do that one? What's another one I could have used?
81 divided by 27.
81 over 27. Is there another one?
243 divided by 81.
Okay. One more. 27 divided by 9. It doesn't matter which of those I use. That's using all the different ones here. We end up with our R is equal to 3.
Wow.
Just use the other one, it's fine. All right, so then for B, let's find our common ratio there. So we could take the 20 divided by 10, or we could take,
40 divided by 20.
okay, or,
80 divided by 40.
okay, we could take any of these, right? And I'm not going to write the last one. No matter which one we use, we end up with R equals.
2.
All right, so we had some easy ones. Now we get to do some fun ones. So I'm just going to work one of these. It already told me in the problem here that it's a geometric sequence, so I know it's going to have a common ratio. How am I going to find out what it is?
You change with it.
Well, first I'm going to give me two numbers there then.
1 over 16 over negative 1 over.
All right, good. And because you're dividing fractions within fractions, so we end up with 1 over 16 times negative 4 over 1. So if I just straight multiply, it's negative 4 over 16, which reduces to...
Negative 1/4.
Good. So we said our common ratio there is negative 1/4. Now, what do you notice about that common ratio with all three of those equations?
They're divisible.
Look at our ratio and look at the equation that was given for that sequence.
I hate myself.
It's what?
It's right there.
It's right there. What do you mean it's right there?
Like
Doesn't equal 0.
It's right there, correct? Where underlined?
Yeah.
And this one's right here. What is that called?
Coefficients.
Not the coefficient, the base.
Base.
It's the base of your exponential part.
Cute.
All right.